If the moon disappeared instantly, Earth would undergo changes like possible tsunamis, a shift in ocean currents, sea life extinctions, and eventual massive climate swings. But if the moon had never existed, Earth would be unrecognizable to anyone today.
Without the moon, life on Earth would probably look quite different. In particular, humans might well never have come into existence.
About 150 million years after a moonless Earth forms, 4.5 billion years ago, it moves out of its hot molten phase and begins cooling. The day is only about 8 hours long.
If we had an 8-hour rotation period, we'd have 4 hours of daylight, 4 hours of night. The nights would be totally black if we don't have a moon.
Once cooled, our planet is temperate enough to retain water. Heat escaping from Earth's core drives steam and carbon dioxide beyond the surface, creating a thick atmosphere.
Over a period of time, many years, all of that atmosphere would have kind of collapsed back out, and then as it cooled, the oceans would have formed in torrential rainstorms.
Icy asteroids continually pummel the planet, bringing in another large source of water. With a smaller, cooler molten core, there are probably no plate tectonics, and therefore no large mountains and huge ocean basins. Water soon covers most of the planet's more uniform crust.
We certainly would have a higher sea level than we have today, less continental area, and that would be a different world. Our blue marble would be even bluer.
Ironically, even with all that water, the early moonless Earth would have smaller tides. Determined only by the gravitation of the sun, they would be just 1/3 the size of our current tides. The range between high and low tide would remain constant throughout the year and would occur at exactly the same time each day.
And that means the intertidal regions would have been narrower, probably leading to less diversification of life and perhaps even impeding the progress of life from the oceans to the land, because it's in the intertidal regions where creatures had to develop the ability to survive both in the water and on land.
With an 8-hour day, just 4 hours of light followed by 4 hours of moonless black, the early Earth spins 3 times faster than today. The winds howl due to the aerodynamics of Earth's quicker rotation.
Jupiter, for example, is a giant planet that spins very rapidly. It has a 10-hour spin period. And it's got ferocious winds in its upper atmosphere, hundreds of miles an hour, and incredible storms like the Great Red Spot, which has been around for centuries. Now, Earth probably would be spinning more rapidly than it is now, and that would generally lead to stronger winds and more violent hurricanes and other storms.
Early Earth's fast spin results in another important side effect.
The rotation of Earth's core, particularly the molten part of the core, is believed to be what generates our magnetic field. And so the Earth rotates 3 times faster, the magnetic field is 3 times stronger.
The enhanced magnetic field over the moonless Earth more effectively deflects high-energy solar flare particles towards the Earth's poles, resulting in larger, more spectacular auroras. But by blocking the solar flares, not as much radiation zaps life in the lower atmosphere, decreasing mutations that drive evolution.
Stronger magnetic field might have slowed the rate at which life evolved on Earth.
Without the moon, the developing Earth suffers intense climate volatility. Over many periods, each lasting several million years, the Earth's axis is pulled and pushed by the sun and other planets without the stabilizing influence of the moon. Conditions would have paralleled what happened to Mars.
What we've learned in the last 15 or 20 years is that Mars has a very unstable axis because it has no big moon. than when we look at Mars, and we can actually see on the surface of Mars geological features that formed under very different climate regimes when the polar axis was tilted over. On Mars, we actually see these features like the dry river channels and glacial deposits and other features, ice close to the equator. And so the big realization was, oh yeah, the climate has been changing on Mars, and this explains that we're seeing older features.
Like the red planet, a moonless Earth's axis would tilt wildly, turning our planet topsy-turvy.
Our axis, over a period of millions of years, would wobble chaotically. It would sometimes be vertical, it would sometimes be close to horizontal. When it's vertical, then the whole Earth might be kind of a tropical paradise. When it's horizontal, you could actually have the poles pointing towards the sun and the poles actually getting jungles. So you would see very big changes in Earth's climate as a result of this chaotic wandering of Earth's axis. And this would make it more difficult for life to flourish because it would constantly have to adapt to different conditions, to ice ages and to extremely hot ages.